Okay, the first thing we're going to do is to recap how in linear algebra, how you found the distance formula. So the distance we're going to calculate here is between the point ABC and the point XYZ. The idea here is I'm just going to put down point ABC down here. Hopefully I won't be getting in the way of too much. What I'm going to do is put a plane right here. We know from earlier that the equation of that plane is just z equals c. And what I'm going to do is just put a axis up like that. This is parallel to the z-axis. What I'm going to do is just walk from the point ABC over to the point XYZ. So what I'm going to do is go walk like this to something, and we'll figure out what I walk to. And I'm going to walk over to here like this. And I'm going to walk up to here like this, where this is the point XYZ. Now we can figure out actually what the coordinates are of each point here. So let's just do this first. Now when I walk from here along here, z isn't changing, right? And y isn't changing. The only thing that actually changes is the x-coordinate. The x-coordinate changes from ABC to whatever the x-coordinate is over here. So this is just going to be the point XBC. Now as I walk along this way, the x-coordinate doesn't change. The z-coordinate doesn't change. The only thing that actually changes is the y-coordinate. So this is going to be the point X, and then y, and then c like this. And then as I go from here to here, the x-coordinate doesn't change. The y-coordinate doesn't change. The only thing that changes is the z-coordinate. Now, that's going to be enough so that we can label how long each side is. So this is just a nice horizontal change. The length of this side right here is just going to be x minus a. This one right here, the only thing that's changing is y, and so the distance here is just going to be the difference between the two y coordinates. And the only thing that's changing from here is going to be the height, and so the length of this is just going to be z minus c. What I want to do is to draw the distance we're trying to find, and the distance we are trying to find actually is this one right here. And so what we're going to do is draw a right triangle. And remember, this is a right triangle that's actually taking a vertical chop that comes down like this. And we just need to figure out how long each little piece is, and that's not going to be so bad. Let's call this S just for distance. Let's call this H because it looks like height. And let's look at this little one that sits down in this plane. We'll call that one L. Now, how am I supposed to figure out L? Well, this is a right triangle right here. It's just sitting in this horizontal plane. So we're going to have x minus a squared plus y minus b squared equals a squared. Let's put that up here. So on x minus a squared plus y minus b squared equals L squared. That's a nice thing to put first. Then we can see from this picture that L squared plus h squared equals S squared. So I'm going to get L squared plus h squared equals S squared like that. And what I think we can do now is just start putting in everything. Instead of this L squared, I'm going to put in this. So I'm going to get x minus a squared plus y minus b squared plus the height squared. Well, the height is just z minus c. So this is just going to be z minus c squared equals s squared. That's what the one we want. And now that we have the equation we want, let's just erase everything else so we can just write it down as a nice conclusion. Okay? Eraser's saying it doesn't want to do that. You can hear how ornery it's being, right? So let's just write this as a conclusion. Ready, set, conclusion. S, the distance, is going to be the square root of x minus a plus y minus b quantity squared plus z minus c quantity squared. and it looks like Pythagorean in 3 variables. You should know that once you get to 4 variables, there's no nice way of actually drawing a picture, but what they're going to do is just follow the analogy, and because of the actually dot product, everything works the way it should, which is really pretty cool. So that's the end of this thing, of finding the distance formula.